Okay, well, thanks for sticking with me, everybody. Here we are with our relay controlled circuit hooked up, functional, and working. If you're here for my last video, you would see that I showed you how to make a relay, relay controlled circuit. If you missed that, you might want to back up and check that out. I'll put it in the description below. But our power is going to flow through the high current side of the relay, which is 30 and 87, and light a light bulb. The way we're going to complete the circuit is by building a low current electromagnet inside the relay that's going to close this switch. We're going to control that with a switch on the ground side that's going to have low amperage running through it. And I thought I would take this opportunity to prove that. So I have a meter here, the snap-on meter, and I have it hooked up in my amperage location. Now when you're testing amperage, the most important thing you want to know is that when you're in the amperage spot of your multimeter, if you were to connect across the battery, you would blow your internal fuse. As this is a fused 10 amp max position, and this one's a fused 2 amp max position. So make sure if you're testing amperage of something that you're not over top of 10. Right now I have a light bulb that's going to draw around 2, and I have a low current side that's going to draw less than 2. So I know that I'm fine here. But what I want to show you is that we're going to test and prove that we have two different high and low currents in our circuit. So set your multimeter up to amperage. I'm going to use the 10 amp fuse position in case I have some boo-boos here today. And I have my leads. When you're testing amperage, what you're going to need to do is break the circuit. So I'm going to test the low current side first. If you remember from building the circuit, the white wire was 85 positive. So that's where the power comes into the relay. This is a perfect spot to test the amperage. So I'm going to hook up my leads to. I'm going to break the circuit, and then I'm going to reconnect the circuit with my meter in place. I'm going to do so with the switch on. When I make this connection, my circuit's going to light, and we're going to be reading the amperage that's going to flow through the low current side of the relay. 0.14, 13, so 135 or something if I change to a lower setting. Okay? That proves that we are well under 1 amp in the low current side of this relay. So to test the high current side of the relay, I would take off the high current side of the relay, which is this blue wire right here. Sorry, I reconnected it and turned on the light bulb. It's only 2 amps, so no harm, no foul there. And I'll do the same thing. So I'll make my connection that I just took off, and I will connect to the high current side. I'm measuring amperage again. Very, very clear. You need to break the circuit if you're going to use your multimeter to measure amperage. And I got 2 amps flowing through my light bulb. Exactly what I wanted to see. So that shows the amperage flow through those 2 different sides. What I'm interested in is testing relays in a vehicle. I think that's why you might be on my channel here today or trying to find some information, is because you have a circuit in your vehicle with a relay not working. So what I'm going to use to test it today is I'm going to use my test light. Okay, I've got a test light here. I'm going to show that when I hook up to the battery, I've actually got this fancy little display on here that's going to show me the voltage. When I test for voltage, I'm going to get a red light, okay, and then the readout of the voltage. If I wanted to test ground with my test light, I simply hook up to the positive side of the battery, and then when I touch a ground connection like I have over here, you're going to notice that my test light goes green and it reads negative 12.2 volts, okay? So that'll be the total voltage across there. Tickety-boo, all good. So normally in a vehicle, you're not going to see the wires underneath. All you're ever going to see is that. You're going to pull that apart. I'm going to shut the switch off. And you're going to see the relay. What I'm interested in is when I'm testing the relay is I'm going to take care of the simple things first. This side of the battery has no switch, so that means that this fuse is hot at all times. 30 and 85 should have power on them. So if I take a look at my relay, I can locate the terminals, which are 30 right there, and 85, which is right here. So if I test with my test light, I should get power, which I do, 12.4 volts and 12.4 volts available at both of these pins. That's step one. If your relay has power at 30 and 85, all it's waiting for is ground on 86. Remember that ground comes from this switch. Think of this as your horn relay circuit in your car. And this ground switch is the switch on your steering wheel. So when you go to test for ground on 86, you're going to need somebody to push that horn button. I'm not going to have to do that because I've got this right here. So I'm going to test for ground. So I'm going to hook my test light up to the positive side of the battery. And I need to locate which terminal is 86. So this is 30 and 85. That makes that by default 86. Because the circuits are across from one another. I'm going to hook that up and close my switch. And my switch has ground. So now my control side I know has power and ground. That means when I plug in the relay, it should click. I know that I have power here. So if you had a circuit that wasn't working in the car, and you had power here, ground here, and you had power going into the relay, and you feel the relay click, really the only thing that can be wrong in your circuit is either the load, which is the light bulb, the wiring that goes to the load, or the relay itself. You can isolate any circuit with a relay fairly quickly. I'm going to plug this in. And of course, mine's going to work, okay? If yours didn't work and you felt this click, the next logical step would be to take your test light, hook up to ground, and go to your load on your vehicle, whatever it might be, your fuel pump, your blower motor, your cooling fan motor, and you would test for power going into it, okay? Then, like any load, it needs a ground. Take your test light, hook it up on positive, and test it for ground. If your load has power and ground and still doesn't work, then it's the load that's the issue. If your relay clicks, but you test and there's no power here, that means that your relay is no good because you did the test already. You have power here. You had power and ground across your control side and it clicked, but maybe your contacts are no good in your relay. So you can write off a relay simply by using a test light, viewing it from up above like this. Make sure when you're doing so that you get a proper wiring diagram for your vehicle when you're doing that test, and you can use these tips to diagnose problems on your vehicle. I hope that was all helpful. Thanks for watching.